polynomial operations. Okay, so the first one, I know you're handwriting these, so I'll give you a second to go ahead and write down number 1. If I start going too fast, just remind me, hey, Mr. Starks, I have to write all this down, you know.
Hey, this is Starks.
3x cubed minus 48x equals 0. So I'm going to pass out to you a factoring flow chart. So the first thing we're going to do here, we're going to double check. So we have two terms on the left. So we have 3x cubed minus 48x. What is the greatest number that divides out of 3 and 48? 3. Good. So we write a 3 out front. But we also have to look at the x's. What's the most number of x's that they have in common?
1x.
They both have at least one x. I can't take away 2 x's, or x squared, because the second term only has 1 to take away. So the most that they have in common is x. We put our open parentheses, so that's out front. We're basically undistributing here. Now we're dividing it away. So what's 3 divided by 3? Not 0, 1. Now I had x cubed, but you pulled one of them out front, so how many x's are left? X squared. Minus, yeah, and remember it's dividing. So 48 divided the 3 we brought out front is 16. And then it had 1x, but we took that 1x away. It's out front now. So there's no x's left. So equals 0. Now you can see we basically just undistributed. So if I were to distribute this back through, what's 3x times x squared? 3x cubed. And what's 3x times negative 16?
48.
Negative 48x. So that takes us back. So if you're not sure, try and multiply it back through and see if you did it correctly. Okay. Now the 3x we're done with. There's nothing else I can do with 3x. But x squared minus 16.
Split that into x squared.
And if you look over here, after you do the GCF, how many terms remain? Remember, a term is anything separated by a plus or minus sign. So how many terms is this? It's 2. So if you look over here on the left column, what is that? First of all, is it a sum or difference? Sum means add, difference means subtract. It's a difference. And is it squared or is it cubed?
Squared.
Yeah. So we call this a difference of perfect squares. So the way we factor this, we do 2 parentheses, 2 factors. And then we just follow the little formula that's on the sheet. So we do 1 plus, 1 minus. And then what times what? If I were to FOIL this out, what times what is x squared?
X.
X times x, that's your first term. And then the second term, what times what is 16? 4 and 4. And the middle term cancels out because there's 1 plus and 1 minus, so therefore there's no x in the middle. So that is how we factor number 1. Now you'll notice the directions say factor and solve. So, does anyone remember how we solve it? This is the easy part. Yep.
I don't remember how you actually do it, but I just remember the x plus 4 would be negative 4.
Good.
Minus 4 would be positive 4.
Good. So at least you remember the process. But basically the way we get that is we set each factor equal to 0 individually and solve for the x that equals 0. So if I wanted to solve for x here, what would I get? You'd add 4 over, right? So we get x equals 4. Now most of you can probably do these in your head. But if you set x plus 4 equal to 0, we'd subtract the 4 over, and we get x equals negative 4. Yeah, now you also, the 3x, that's the greatest common factor. It is a factor. So we still have to set 3x equal to 0. Divide both sides by 3. What's 0 divided by 3?
0.
Yeah, so but that is an answer. So x equals 0 is an answer. So you got 3 answers there. If you remember back to Algebra 2, those are the x-intercepts of the graph. But we'll talk more about that on a later test. All right, how is number 2 different than number 1? Starting off, what looks different? There's a negative 6, it's not equal to 0. That's probably the main thing, right? So to factor, it has to be set equal to 0. So the first thing we're going to do, we're going to go ahead and add this 6 over to the left side. So that gives us 5x squared minus 13x, and now that's a positive 6 on the left side. Now those cancel out, there's nothing over there anymore, that's a 0. So just to emphasize, what's always the first step of factoring? So get everything equal to 0, but then like on your flow chart, when we're actually factoring, what do we do first? Greatest common factor, yeah, GCF. So do 5, 13, and 6 all divide by the same number? No, and the last one doesn't have an x, so there's no GCF. But you have to be careful because if like they're all even numbers, like 2, 16, and 4, what could you factor out? A 2. So that's something that does happen. But there's no GCF. So the next thing we do on our little flow chart is determine how many terms it is, because that tells you how to factor. So how many terms are on the left side? 3 terms. Good. So we call it bottoms up. So I didn't write the directions on there. Hopefully you remember it because we've done it for like 2 or 3 years now. But some of you might know it as the A times C method. But the way we do this, we're just going to take the number in front, which is 5, and multiply it times the number in back. So 5 times 6 is 30. So write that off to the side. Now we have to find the factors of 30. So something times something is 30. So I like to make a little factor tree here. But those same 2 numbers have to add up to the b value. Now, that doesn't work because negative 15 times 2 is negative 30. But notice this is positive 30. So what's the only way to multiply and get a positive number, but when you add them to get a negative number? They both have to be negative. It is negative 10 and negative 3. Good. So just be careful. Negative 15 and 2 is a good answer, but it doesn't quite work with the pattern. Okay? So then what we do, we put those numbers in our factors. So we have x minus 10, x minus 3 equals 0. So first step, a times c, find the factors of a times c to add up to b. You guys remember this? Okay, now we're not done yet because if I FOIL this out right now, x times x is x squared. It's not 5x squared. We're not done because it doesn't take me back to where I started. So what's the next step, bless you? Bottoms up. Good. Divide by a, the number in front, which is 5. So bottoms up, that gives us our bottoms. You have to have bottoms to have bottoms up. So divide by a, divide by a. Now if they reduce, it's usually pretty obvious. Like what's 10 divided by 5? Yeah, so that's just x minus 2. Now what happens if the fraction doesn't simplify? Like 3 over 5, those don't divide by the same number. Yeah, so that's where it gets the name bottoms up. So we get 5x minus 3 equals 0. Now I know the video last week covered some of these. I'm just going over them again so you can ask questions and make sure it's good in your brain. Now that's the factoring. So if the test asks you to factor, you'd stop right there and circle your answer. Those are the factors. But this says factor and then solve. So we just have that one extra little step at the end where we're going to take x minus 2, set it equal to 0, add the 2 over, so therefore x equals positive 2. And like I said, most of you can probably do these little equations in your head. That's fine. You don't have to show your work on that part. It's easy enough. So on this one here, I know I'd add 3 over and divide by 5, so it's going to be 3/5. But if you weren't sure, just set it equal to 0. We know we have to add 3 over first, so that gives me 5x equals 3. Divide both sides by 5 to get x by itself. So therefore, we get 3 over. And just leave it as a fraction, no decimals. 3/5 would be our answer there. All right. The next one, I just want to do a real easy add and subtract. So I'm going to make kind of like a 1b here, or I'll just make another example. So example, so I have one polynomial that's 2x squared plus 3x minus 1 plus negative 2x squared minus 4. Go ahead and write that down with me real quick. So we're adding two polynomials together. 2x squared plus 3x minus 1 plus negative 2x squared minus 4. Now, if we're adding together, all we're doing is we're just combining like terms. So, if I start out with 2x squared, and then I add negative 2x squared. They're both x squared, so we can add those together. What do we get? 0. Yeah, 2 minus 2 is 0. So those actually cancel out. 2 plus negative 2 is 0. And then in front, we have a 3x. So 3x plus, are there any x's over there? No, so it's just 3x. If there's nothing to add, it just stays the same, right? So 3x and that's it. And then last we do our constants. So negative 1 plus negative 4 would be negative 5. Good. So that is your answer. Nice and simple. But when we're adding together, you just combine like terms. So what I see all the time is people see this and they totally ignore the plus sign, and then they start doing all this crazy FOILing, and then they have this problem that's like 5 lines long of multiplication, and it's not distributing, it's just adding. That's all it is, just add. Okay? So don't confuse that with what we do in just a minute. Okay, and then the next one I want to do is a subtraction, because it is a little bit different. So write this down with me. Negative 3x cubed plus x squared minus 4 minus negative 4x cubed plus 2x squared minus x plus 1. Now, subtracting is different. So let me ask you this. What's 5 plus 4? What's 4 plus 5? 9. Does the order of adding matter? No. But what's 5 minus 4? What's 4 minus 5? Yeah, so does the order of subtraction matter? Yeah, it's very different. So when we subtract, it's the first thing minus the second thing. So the first thing is what it is. So I like to rewrite it outside of the parentheses. I don't need the parentheses because it is what it is. That's what we're starting with. But subtracting 4 different things means that you have to subtract each of those 4 things. So in other words, we need to distribute this negative through. So what's minus a negative? So that becomes plus 4x cubed. And then we have to minus the 2x squared. So that's minus 2x squared. And then we have to minus negative x, which is plus x, right? Minus a negative is plus. And then we have to minus 1. And now we're just back to the one we just did a second ago. Now we just combine like terms. So there's just like one extra step in there. You just take the negative through. So if we combine like terms, I have negative 3x cubed plus 4x cubed. So how many x cubes do I have? 1x cubed. Good. And then we have an x squared minus 2x squared. Negative x squared, so 1 minus 2 is negative 1 x squared. Now, in standard form, we go from largest exponent to least. So what's going to come next, the 4 or the x? Yeah, so then we'll write plus x, right? Because that's the only x. So plus x And then we have our constants. So -4 minus 1 more, -5. So that right there would be your answer. So just be careful when we're subtracting. You have that first step at the beginning where you need to distribute the negative through and make sure you're subtracting everything. Okay, the last type of factoring that I wanted to do today is number 5, factor by grouping. So go ahead and write down number 5. All right, what do you think our first step's going to be? Subtract the 4. So minus x minus 4 equals 0. So how many terms are we actually factoring? Yeah, there's 4 terms on the left. So if you take a look at your little flow chart, I call this the skeleton. See on the right side it says 4 terms, factor by grouping. So you start out with some polynomial with 4 terms, okay? Now if you kind of follow along the skeleton, it tells you what to do. So see how an a comes out front of the x plus c? That's telling you to take the GCF out of the first 2 terms. So we kind of split it in half. So we're ignoring this for a second, totally ignore it. What is the GCF of 4x cubed plus 16x squared? 4x, and then they both have x squared in common. Now if you divide that away, from the first term, you're left 1x. What's 16 divided by 4? 4. So plus 4. And I had an x squared, but I took an x squared out front, so there's no more x's for that second term. So that's what the little skeleton, it's a skeleton down here, that's what it means by bring the a out front. Now, what do you notice happens with the second half in factor by grouping? The same thing, the b comes out front. So there's another GCF of the second half. Now this one's maybe not quite as obvious. What do negative x and negative 4 have in common? Yeah, negative 1. So we can write minus 1. That's like the b value of your skeleton. So you factor out the GCF, and what is left behind if you take the negative away from both of those? Positive x plus positive 4. Bless you. Now if you did this right, these should match. So can you see on your little skeleton how they're both x plus c? They should be the exact same. That's what that means. So now if you look at the last line of the little skeleton, what comes out front? What's the first parenthesis going to be? The x, well look here, it's x plus c. You see that? So what's our x plus c? X plus 4. So x plus 4 comes out front. And then what's in the other parenthesis? Yeah, the a and the b value, the 2 GCFs. So 4x squared plus u minus 1. So that's kind of how that little outline works on the factor by grouping on your flowchart. So if you ever forget, hopefully that'll spark your mind. Yeah?
You can keep going and do like 2x minus 1, 2x plus 1.
Exactly. Good job. So anytime you should have an x squared, you should be weary that it's going to break apart further. So obviously the x plus 4 is done. But how many terms is this? 2. So you should be looking in that left column again. So that is one of those scenarios on the left side with an x squared. So what do we call that? It is a difference of perfect squares again, because 4 is a perfect square, 2 times 2. 1 is a perfect square, 1 times 1. And x squared is a perfect square, is x times x. So we do our little patterns, 1's plus, 1's minus. And then what's my first one going to be? What times what is 4x squared? 2x and 2x. And some people forget that 1 is a perfect square, but what times what is 1? Yeah, 1 times 1. So plus 1 minus 1. So hopefully some of these things are kind of coming back to your brain. Last step is the easy step. If I have to solve this, I'd get negative 4. Subtract 1 over, divide by 2 is negative 1/2. And then add 1 over, divide by 2 is positive 1/2. So 3 answers. So it looks like it's multiplying, but if you remember from last week and the week before, what does a negative exponent do to whatever it's the negative exponent of? It moves it to the bottom. So really, what this is telling us is divided by m plus 2. It's the same thing. The negative exponent means division. So ultimately, it is a division here. Now, you can only do synthetic division if you're dividing by a single variable plus or minus a number. So like m plus 2, m minus 4, m plus 7, okay? If there's a number in front of m, so if this was like a 3m plus 2, you'd have to do long division, okay? So this is a shortcut, but it only works if the variable's by itself and there's not a coefficient in front, okay? So the way this works is real easy. Just got to remember the process. The first thing we do is we set m plus 2 equal to 0 and solve for m. So what is m? Negative 2. That is the number that we put in the top left box. It's going to be the opposite of m plus 2. So if there was m minus 7, what would you put in the box? Positive 7. Good. Now what you have to do, in a row after this, we put the coefficients of the polynomial that we start out with. So this is a 1m to the 4th, so I'll put a 1. And then negative 3, so negative 3. Now what's missing in this polynomial? In standard form, from largest exponent down to the smallest, what's missing? There's an m squared missing, right? Does everyone see how there's no m squared? You have to put a 0 there. Same with long division. If you're ever missing a term, you have to put a placeholder. So hopefully the video touched on that last week. And then we have a 5, and then we have a negative 6. And then leave a space, draw a line, and put a little box under your last number. What do you think that box down there is going to be?
Remainder.
Good, that's your remainder. So you can put a little R by there, remind yourself. So the way we do this, you always bring down the first number. So you get a freebie. Bring down the 1. Whatever it is, bring it straight down. And now you multiply what you brought down times negative 2. So what's going to go here? Negative 2. Now you might make a little note. We add down. So it's negative 3 plus negative 2. Negative 5. And then you multiply what just came down times the negative 2. Add down. Multiply. So negative 2 times 10. Add down. 5 minus 20. And then multiply. The negative times a negative is a positive. Negative 6 plus 30 would be 24. Now that's it. Goes once you get the hang of it, it goes really fast. You can probably do that in like 30 seconds, okay? But now we have to write out our answer. So the way this works, the number in the box is the remainder. This is the constant. This is the x. This is the x squared. This is the x cubed. And if it was even bigger, it would just keep working its way backwards, okay? So my final answer would be x cubed minus 5x squared plus 10x minus 15. And then, do you remember from the video last week, how do we write the remainder? Oh, sorry, I used x's. My fault, whatever. Sorry, if you did m's, that's okay. My bad. But then you do plus, because it's positive, or really you can always do plus. And then whatever the remainder is, which is 24, over what you're dividing by, which was m plus 2. Sorry, I used x's. All right, x plus 2. So the remainder over what you were dividing by. So that is your nice, beautiful answer. Actually pretty ugly. Now there are a few things that you need to know, okay? So on the test, it's going to ask you these words. So what was this called again? That's the remainder. So if it asks you for the remainder, you can write 24, or you can write 24 over x plus 2. Either one of those is fine. Does anyone know what the answer is called? Like this part of your answer? Someone said it? The quotient. So the whole part of your answer is called the quotient. And then what you're dividing by, which is up here. So what you're dividing by, which is obviously also down here. Sorry, I'll do a different color. That's called your divisor. Those are the 3 vocab words you need to remember. So hopefully remainder is pretty easy. But then the quotient is your answer. What you're dividing by is the divisor. So that's what I think in my head. What you're dividing by is the divisor. What you're dividing by is the divisor. Bless you.